Hello, everyone. As Sarah said, my name is Ben Gable. I am a developer advocate working in games, and I'm super excited to be here today. Two reasons. I used to be an ex-indie game developer myself before I joined Google, as Sarah was as well. And also I went to school at DigiPen Institute of Technology over in Redmond, so Seattle is kind of my old stomping grounds. So kind of continuing the flow, there's gonna be a lot of information. I'm gonna be going through it very kind of quickly to stay on time. So I'm here to talk to you today about building an awesome game in Android. And really, what does that mean? Well, you guys know how to build awesome games. It's all about building a high quality game in Android. You know, Android is the largest mobile operating system out there, and it means there's tons of people all around the world that are gonna be playing your game on different devices, on different versions of the OS, and you know, it's a huge challenge. And you want to make sure that you're developing a super high quality game so that when somebody picks it up on a certain device or a certain version of Android, they don't have a bad experience. Because if they have a bad experience, it could turn into bad reviews, or they could uninstall it or not tell their friends about it. So it's super important to kind of consider all the different places and ways that people are going to be experiencing your game on Android. And really this breaks down into two areas I'm going to talk about today. So the first two areas is kind of like what's new in Android from a technical perspective, and kind of what are the new branch. So there's a new branch called Chrome OS that we'll talk about a bit. And the second part is going to kind of touch more on, you know, as indies, resources, you know, having resources to test and make sure that your game is delivering a high quality experience is hard. So I'm going to talk about maybe some solutions that you can consider that will hopefully make that a lot easier for you guys. So let's jump in. So Android P. This just came out a couple months ago, and one thing I wanted to bring up before we jump into Android P is there was a new play requirement that actually just yesterday, you need to be targeting API level 26 or above in order to launch any new updates for your game. So if you weren't already aware of this update and you're planning on launching an update soon, you might have some extra work to do. So please be aware of that. But the bigger thing I wanted to bring up is next year, we have a new requirement coming, which is kind of more relevant to game developers, and that's you'll need to ship a 64-bit version of your game for whatever architecture you're targeting. So, you know, this is something that you could have lots of external dependencies on third-party plugins or something, or your game engine. You know, you might have to consider updating your game engine to support a 64-bit build. But as more and more 64-bit only devices are going to be launched in the Android ecosystem, it's important to make sure that games are available. So again, kind of continuing the theme of making sure that you're aware of all the different kinds of flavors of devices that people are going to be playing your game on. So notches have come to the Android ecosystem. If you guys have seen Pixel 3, I am personally not a notch guy, but a lot of people are. So it's important to consider that your game might be being played on an Android device with a notch. So we've added a bunch of APIs, best practices online, and actually some developer tools where you can simulate notches on a device. So I recommend that you take a look at how your game is running on a notched device and make sure that the UI is not being cut off or there's other rendering issues that are happening there. Notifications. Notification channels are now compulsory as of API level 26. So you'll need to specify a specific channel for each one of your notifications. And basically what this lets users do is activate or deactivate certain channels that they maybe care about, and also they can customize the behavior of each one of the notification channels. So really what this means for you guys is to think about what kind of channels you're putting your notifications in and not spamming the user, and kind of being aware that people might be turning things on and off as they upgrade to Android P. For NDK, there's been a bunch of new stuff that I will kind of go over briefly. Basically, we've added APIs for neural networks and the JNI shared memory, so that's a huge deal and super exciting. We have now Clang++ is the default compiler for NDK builds, and libc++ is now the only STL implementation that comes with the NDK, so please be aware of that. And then also we've now got the LLD linker as of R18 is available for testing, which we've seen can greatly speed up your linker times. So you know, sometimes building and deploying is super slow. So I recommend you check that out as it could help you speed up that process greatly. Okay, some other Android P features. We've got AR Core, Vulkan 1.1 support, neural network APIs. We've got a job scheduler for background workloads, which should be super interesting for, super helpful for some of you. And also we've got a indoor location API, which you guys being indies come up with the craziest ideas. I'm sure somebody will come up with an amazing game idea based around that. So excited to see what you guys do with it. Cool. So now let's jump on to games on Chrome OS. So maybe a quick question. How many of you have used the Chromebook before? Or, yeah. Okay, so some people. And how many of you were aware that your Android games can now run on Chromebooks? Okay, a few more. But not a lot, so this will be exciting. So if you didn't know, Android games can now run on Chrome OS. So you can see here on the right, we've got the Pixelbook, which is a more traditional laptop-style device. And just announced was the Pixel Slate, which is coming out later this month, as a tablet with a detachable keyboard. And Chrome OS is, as I said, games can now run on Chrome OS. So your Android game is probably running on Chrome OS right now, and there's probably people that are asking to play it or are already playing it. The biggest ask we've been getting from users on Chromebooks is they want to play games on it. And Google's putting a huge amount of effort into kind of building out the Chrome OS ecosystem. So again, kind of going back to building that high quality experience, you might have users that are playing on Chromebooks, and you should be aware that they could be playing on Chromebooks. So this is a kind of a huge new area of Android that presents a huge opportunity to collect more users and also play it in a way that for your game, for specific your gameplay design, might actually be a much better way to play it. So Ben, you might be asking, deploying and testing on all these versions of Android is already hard. Device fragmentation is real. I'm an indie dev, I know how that goes. How can we possibly support Chrome OS? Well, the good news is that most of it is probably already done for you. The Play Store is the same on Chrome OS and mobile devices currently. So if it's on the Play Store right now, it's probably running on Chrome OS. There's a few permissions and stuff that if you're asking for, it'll list it as incompatible, but we can talk about that later. It's the same APK on both Chromebooks and mobile device, so there's no extra libraries, no other plugins you have to integrate. It just works. And as we've seen, a lot of times, 90% of the time, the games work great. But with that said, there are some key differences that I'll touch on in a moment. So how does this work? Basically, on top of the Linux kernel on Chromebooks, you've got Chrome OS, and you've now got the Android container. So it's not a VM, it's Android running natively on top of the Linux kernel. It's the full version of Android, it's not a stripped down or special version. So anything that works on a mobile device works on Chromebooks. So that makes it a lot easier for developers to target and support it. And moving forward, so you can see Android P just hit the Canary channel for Chromebooks a couple weeks ago. Moving forward, all the major releases of Android will also hit Chromebooks, and they'll basically be in sync. So again, important to kind of consider that this is happening. So as I mentioned, there are some key differences that you should be aware of. So first off, you've got the bigger screen, so more pixels to render. Could look at performance. Also, you could look at UI considerations. You've got all this extra screen real estate space to take advantage of. Default landscape orientation. So those of you with a portrait default orientation might want to take a look at that. If you don't do anything, there might be some giant, ugly black bars there that are no good. On Chrome OS, dynamic resizing is the default. So when you launch any kind of Android app, it's in a window that can be dynamically resized. Fortunately, in the game world, we don't really deal with dynamic resizing, and a lot of game engines don't handle that very well. So consider maybe disabling dynamic resizing or just locking to full screen. And then kind of obviously the biggest difference is now you've got a keyboard in the case of the Pixelbook attached to the device. And as we see more and more games kind of blurring the line between consoles and PCs, you've got things like PUBG, Fortnite. The same gameplay that's on PC is now coming to Android. Obviously, implementing keyboard and or mouse controls could be a huge benefit to provide the best possible game experience for your Android players on that device. So consider that. Also, one thing that's not listed here is that a lot of mobile devices are ARM-based, and a lot of developers don't ship an x86 version. A lot of Chromebooks are x86-based. So you should be aware that you might see some performance degradation due to the translation that happens when you try to do an ARM. So an ARM APK will run on an x86 through Houdini. It's a translation layer, but you'll kind of get that overhead there. So if you can ship an x86 version, you should definitely take advantage of that. So Vainglory is a MOBA, for example, developed by Super Evil Megacorp. They implemented full skill bindings for their keyboard skill bindings and item usage. And they still left the touchscreen controls in. And they actually told me they found an interesting kind of hybrid approach where you can tap the screen to select enemy heroes much quicker than with a trackpad, and then use the keyboard to kind of fire off skills and items. So they found a lot of their pro players actually prefer that input method compared to the one way or the other. And then Gameloft has developed Asphalt 8 and recently Asphalt 9 for Chromebooks. And on mobile, they're just a tilt and touch-based control, but on Chromebooks, they actually detect that the keyboard is connected and allow you full WASD and arrow key controls. And obviously on the bigger screen, it looks a lot better too. They've got some great graphics. And the other interesting thing that they found is that when they launched Asphalt 8, they found a 6x increase in daily active users and 9x increase in monetization, which kind of, again, speaks to Chromebooks. People want to play games on them, and I think this kind of speaks to players are clamoring for it. So one other quick note is that Linux is actually on Chromebooks now too. So there's a full Debian VM running on Chromebooks that you can actually install Android Studio. You can install Steam. It's not very fast yet. Don't worry, I tried. But we're really working on trying to improve compatibility and speed of the Linux VMs. So definitely check that out if you get a chance. Cool. So that was a quick run through of these big new branches and areas of things that users are going to be experiencing in the Android ecosystem, and you as game developers should try to be aware of these new features and these new kind of devices that people are playing on, and try to target that and provide the high quality experience. Now let's talk about testing and how you can, from that aspect, provide a high, stable performance, no crashing, fewer bugs. So we've got some tools that we'll talk about here. And the first off, in Android Studio 3.3, you can now sample native C++ threads. So for any app that is API level 26 or above, you can do this. So maybe a raise of hands, how many of you have never, ever left debug logging code in production code when it's shipped? Anybody? Okay, good, because I was going to call him a liar. So now if you've done something like this, it might do something cool function. Inside Android Studio, I can see that my do something cool function is doing something not very cool at all, and I can fix that. Systrace is now coming to Android Studio. It's not quite in Canary yet, but it's coming. And basically, Systrace kind of gives you a snapshot of how your game is running on the Android, in addition to the Android system. So you might be using Unity or Unreal or have your own kind of profilers that are happening, but they might not give you as much detail about how your game is running in terms of the rest of the system processes. So inside Android Studio, in a bit, you'll be able to see kind of this whole view. So you'll see up on the top, you've got the CPU time, you've got your different CPU cores, you've got all your threads, display of all the threads that are running, and at the bottom, you've got your call chart. So there's a couple of really useful use cases for this that will hopefully make debugging and profiling and optimizing for Android much easier. So the first here is you can see that we've highlighted this thread, and I don't know if you can see it, but there's some red frames right there, so that kind of indicate that those are slow frames. So you can dig in and kind of see maybe outside of your game why something might be causing those slow frames. And here you can actually see on this, we've highlighted this thread. You can see it's jumping across the different CPU cores, which could be causing some performance impact. So you might consider setting thread affinity for that specific thread to kind of stay on one core. And here we can see that this is a very, very terrible frame. It's taking a long time. But now inside Android Studio, you'll be able to dig in and figure out why it's so slow. You can see down at the call chart at the bottom, there's multiple calls to inflate, which obviously is inflating the frame time. So super useful tools that are coming very soon that we hope you guys will kind of take advantage of and hope it provides value. Also, a super exciting, I think this is the biggest thing, is you'll be able to basically instrument and provide your own events for your game. So you could do things like set events around your loading screens. You could set events around your shadow passes or other areas of high intensity gameplay where your performance is a problem. And basically, that'll show up inside Systrace much more clearly, and you'll be able to get those deep insights that you need in order to optimize for Android. And in the future, we're working on adding more support around viewing vsync events and timing around that. So there's some other things coming too for games that will be announced shortly. Cool. And then one of the other tools that I wanted to bring up was Gapit. So Gapit is basically it's our graphics API debugger. It's basically lets you trace, inspect, and replay all of your draw calls. So for example, if you've got some weird graphical bugs or maybe some performance is not as you expect, you can sample a portion of your gameplay. You can go through all the frames, all the draw calls, view things like models, textures, shaders, basically view everything that the system is doing to compose that frame. So it gives a lot of insight that you might not be aware of to help debug issues. It supports both OpenGL and Vulkan based games, so if you're doing either one, you should be covered, and it runs on both Windows and Mac. Cool, so now let's talk about game testing, which we know game testing on Android is hard. All these devices, all these different versions of the OS. A lot of the existing tools are also not built around games. So we kind of went on a quest. We wanted to find a solution that was easy to write scripts inside of an IDE. You could run it on your local device, run it maybe on a farm of devices in the cloud somewhere. Simple to use and confident in the results. And we actually found a solution being built by a Chinese game developer called NetEase, called Airtest. And basically what it lets you do is test your production APKs with no instrumentation required. You can run it on your local device, and it also integrates with Firebase Test Lab to test it on to run these tests on the cloud. So you can see here the IDE, but I actually got a video here that will kind of go through it. So you can see on the right is your game, and then in the middle is kind of your script window. And as you play through the game like you would normally, it's writing a test script for you. So it's trying to do all the things that you do on what you're doing. And basically, what you can do is you can write out this entire script. You can tell it to do things like click on buttons, assert that player models that should be there are there, move things up and down. Basically, anything that you could do playing the game, Airtest can also emulate it. And then what you do is you run the test, and it actually plays through your game. Each step gives you all the output. And for each step in the test, after it's done, it'll give you a report here, we'll see in a second, that shows you the results of all those steps. So it'll show you what steps failed, if there's any warnings or errors. It'll give you a log of all the screenshots of all of the different steps. So it's really useful to kind of maybe do this for things like first-time user experience or a tutorial level or just other kinds of boilerplate areas of your gameplay that you might test at one point and everything works fine. You go and you do a bunch more changes for a couple more weeks, some new features, and then you go back and everything's broken. So this is a great way of kind of writing these tests and automating the whole process that you don't have to do it over and over and over again. And kind of underlying Airtest here is there's two frameworks that work. There's Airtest, which is using image recognition, just looking at the pixels on the screen. And then if you want more integrated testing or more kind of complex test cases, you can integrate Pocos, which is basically, it exposes the UI and object hierarchy inside your game. And there's plugins for Poco for Unity, Cocos, and other custom game engines. So you kind of have two flavors you can use depending on how deep you want to integrate this testing solution. And the really interesting thing here, and kind of the most exciting thing, is that this all integrates with Firebase Test Lab. So what you can do, I guess those of you that don't know what Firebase Test Lab is it's basically a cloud of devices. There's physical and virtual devices running all different kinds of the Android OS. And you can upload tests to it, and it will test your game for you and give you reports. And with Airtest, you can basically build your test APK, you can upload it to Firebase Test Lab. You can create a suite of these automated tests that will then kick off whenever you want. There's actually a command line interface to hook into your continuous integration. So every time one of your developers pushes a change, it'll kick off these tests. And select which devices, which versions of the OS you want to target. And it'll actually give you a very detailed report that shows you all the failures. It shows you all the system logs. It'll actually give you a video replay of your tests of your game running. So you can actually see and verify that what you thought it was doing is actually being done. And it actually gives you performance data synced to the video. So you can see things like CPU time, memory usage, network usage. It's basically a QA army at your fingertips. So it's super exciting, and I think this is like one of the biggest challenges for indie game developers is that you don't have a lot of resources to test your game. You're trying to build a game, not necessarily test it. So being able to set up these kind of automated tests and just have them running over and over again, make sure that you're kind of maintaining that high quality bar and delivering a great experience. So here's some links for more information. You can find the ID at Airtest, the first one, and then we've got some GitHub projects. And now let's talk about Vitals. Sarah kind of briefly mentioned this, but Vitals, Airtest and Firebase Test Lab are for pre-launch, development, building new features, testing. Vitals is basically a way to see, you get actual data from devices that have opted into the Android Vitals kind of diagnostic system. So you get actual reports from actual user devices out in the wild that are actually playing your game. So this is a huge deal. And why we made this is that basically we found that 50% of one-star reviews mention stability and bugs, right? Again, providing that great experience has a really big impact on your rating, which impacts your success. It's one of the many ways that you indie developers kind of create success. So it's important. And you might have seen this already in your Play console, but you can go in and you can look at your Android Vitals report. It'll give you kind of a detailed breakdown of all the different crashes and all these kinds of other things that Vitals is monitoring for. And some of the ones that might be of interest to game developers specifically, obviously, these are kind of the bad behaviors that Android Vitals tests for. So you've got crash rates, you've got ANRs. Around battery, as Android P has introduced a lot of new kind of battery and power measuring tools for the users. So if your app or if your game is up at the top of this list of it's a power hog, that puts you in a dangerous territory of potentially getting uninstalled or used less. So making sure that you're not waking up the system too often, or you don't have any stuck wake locks when your app tries to get backgrounded. If you hold on to things like audio handles or stuff like that, your game won't be backgrounded properly and it continue to draw power. Cool. So let's recap real quick. I went through a lot of information, and really, again, it's kind of it's providing a high quality experience, because that really directly impacts the success of your indie game in the hands of users. So the first two parts, I kind of talked about was, consider where the users are going to be playing, what kinds of environments your players are going to be playing your game in. So all these new Android P devices that are out there have these new features. Maybe consider how you might integrate those new features. Consider that people will probably be playing on Chrome OS moving forward, and that you should make sure that your game runs great on Chrome OS. And then the second part, is really, again, once you ship a high-quality game, maintaining that quality bar. So profiling and optimizing your game so it runs great on as many devices as possible. Testing early and often, and using things like Vitals to attack production issues quickly. So all of these things kind of come together and will allow you, hopefully, I hope you found at least one thing in here that will maybe help you guys kind of provide that higher quality experience and kind of take some of the load off so you can focus more on building gameplay and the super awesome kind of innovative features, and some of the more boilerplate kind of game quality type stuff. Hopefully there's something in here that's useful for you guys. So thank you very much for your time.